Okay, so welcome to our live YouTube chemistry lesson for the year 11, okay, from Aspiration International School. So, do participate by putting your thoughts in the live chat. So, this is live. So, any questions you have, you just put it in the live chat. Okay, I will look at it and I will definitely answer your question. So, this is only going to work, right, if you all participate. Okay, so we're going to start. Okay, so as you can see with the title, we are doing revision on organic chem and rate of reaction. Okay, so I think it's helpful that because we have already finished the syllabus, so during every class, what are we going to do, right? So we are going to do short revisions, okay, and then focus more heavily on certain topics. So that's how we are going to do, and then very soon I'm going to assign past year papers. I just did not want to stress you all up with the past year papers because we have the test maybe after this week, all right, when there's not really, I mean, maybe after the exam, I don't know, all right, we'll slot in some past paper homework for you all to do. Okay, so we are going to start. Okay, I hope. Okay, I'm gonna speak louder. Okay. uh okay. All right. Apart from, is this okay? Everything else okay? Can I start now? Okay. Let's start. Read through this question and let me know what you think. So now, as you are hammering down the answer to this question, let's go through a little bit about rate of reaction. Okay, so rate of reaction, okay, usually we talk about increasing rate of reaction, right? Okay, so we talk about the particles moving faster. You can talk about the particles moving faster, or you can talk about the particles gaining kinetic energy. Okay, now, therefore, we talk about higher rate of collisions. Okay, definitely it's the higher rate of collision between particles. All right. After that, we talk about higher chance of successful collisions. Okay, so this is how we normally go. All right, but be careful, right? Only if the particles move faster. So guys, can you answer me? In what situations will the particle move faster? In what given situation will the particle move faster? Yes, so it's not always you use all three. Okay, it's thank you guys. It's not always you'll use all three. So for increased concentration, when the particles do not move faster, you can use the higher rate of collision. All right, and the higher chance of successful collision. So be careful, right? This one you only use for temperature. Now for temperature and catalyst, they want you to talk about activation energy. So I hope you know about activation energy. So remember, so if you do increase the temperature, then you say there is a higher chance of also overcoming activation energy. So this is important. So increasingly more in the later years, they would want you to include activation energy. So this is a very, I would say, a good revision on the, so besides temperature, when do we use activation energy? Besides the change in temperature, in what situations will we use activation energy? Can you put in the chat the answer? Besides temperature, what is another situation where we use? That's right, it's a catalyst. So remember, okay, another thing is this, right? This is chemistry, all right? So this is not English literature or, English language. So this is science, and you need to use keywords in order to get the marks for IGCSE. So remember, for rate of reaction topics, for rate of reaction questions, you will need to mention the factors. So you need to be very clear, like the factors of rate of reaction. And I find that students are very, very lacking here. Okay, so please, can you straight away hammer down all the factors of the rate of reaction? Can I see? I think in total there are 5, right? Hammer down all the factors of the rate of reaction. Can I see them, please? Hey, don't put one by one like that lah. Put all in one line lah. Anyways, okay, you have temperature. Okay, you have catalyst. Okay, yes, very good, Ian. Concentration. All right. Um, and we have pressure. And we have surface area. So it's mainly these 5. So yeah, so very often, when students answer, very often they don't use the factors. They use things like volume, which is not a factor. Okay, so you got to use one of these keywords here. And remember, under catalyst we have light. And I hope you remember photochemical reactions, right? You need to know at least 3 photochemical reactions. So that's the brief revision on rate of reaction that I just wanted to share. Now, previously you all put the answer as B. I haven't even read the question, yeah? By increasing. Yes. So increasing the concentration does not affect the kinetic energy. So yes, the answer to this question is B. Well done, all of you. Well done. Are we ready for our next one? Remember, if you disagree with any question or you're not so sure, remember to put down your questions in the live chat. All right, moving on. So there you see you have collisions, and then after that you have activation energy. So what is activation energy? The second part of the question, proportion of molecules with sufficient energy to react. So sufficient energy to react refers to activation energy. So they want both, affect the rate of collision and activation energy. So I think the answer here is pretty obvious, and all of you got it. Well done. Thank you for participating. Yes, the answer to this question is D. All right. Well done. Well done. Moving on. Alright, so here they are again talking about concentration. So the 2 mole per dm cube, this is concentration. And of course, 25 degrees Celsius, that is just the temperature. So what will increase the rate of reaction? Again, it's a D. Very good. Yeah, so although temperature stays the same, concentration increases, therefore rate of reaction increases. Now I hope you all have okay, so I hope that you all have printed this out. Okay, so yeah, or put it in whatever platform that you feel comfortable with. So what is meant by the term catalyst? Well, okay, of course it is a substance. Okay, it is a substance that speeds up the rate of reaction. All right, um, without being uh, used up or without being changed chemically. Okay, and it does not alter the amount of products. So this is the complete answer, okay, when it comes to what is the term catalyst. So I hope this is clear. Okay, I hope this is clear. If you have any questions about any of the points here, please write them down. Amazing. Very good. Very good. Well done. Thank you for participating. Good answers. Moving on. There we have. So now, can we talk a bit about the graph? So um, how do you calculate the rate of reaction? Of course, you have here the physical quantity. Now, the physical quantity can be the mass, can be the volume of the gas, and you have time. That's why I made it, I always emphasize, how do you calculate rate of reaction? You need a physical quantity and you need to measure the time. Now look at the curve of the graph. The graph is always like that. Okay, so now I will have you note that this is the point of the highest rate of reaction. Then as you go along, all right, you have decreasing rate of reaction. And of course, when you reach the plateau here, the reaction is over. Okay, so they will sometimes ask you a question, what happens to the rate of reaction? So your answer will be it decreases over time. And that is the answer to this question. What happens to the rate of reaction as time increases? All right, did any of you put down any answer? Oh, haven't put down any answer yet, yeah? Yes, Alicia. Catalyst, right? It lowers activation energy. I missed that out. Fantastic, fantastic, fantastic. Yeah. So, what happens to the rate of this reaction as time increases? 4 marks, yeah? Marks. Wow. Well, so I would say rate of reaction decreases over time. Okay? Yeah, what's the second thing you can say? Okay, remember to use one of the key factors, right? So we say the concentration. So they will also allow amount. So the concentration, okay, or the amount of the hydrogen peroxide decreases. So when the amount, okay, of the concentration of the hydrogen peroxide decreases, well, you can say that is lower rate of collisions. Okay, then at the end of the day, all right, yeah, I think this somehow one of them will give you 2 marks. So yes, well, if of course you don't feel confident, you can say that the rate of reaction becomes 0 as the hydrogen peroxide is used up. So you always try and bring in collisions. In rate of reaction, you always try and bring in collisions. Volume decrease cannot go, man. You need to have collisions. You need to have concentration, not volume. Yeah, concentration. You see, like Manraj, you wrote hydrogen peroxide, yeah? But you need to be, it's better to use concentration. I hope this is clear. I hope this is clear. Thank you for participating, yeah? Now, the experiment is repeated using the same mass of magnesium oxide. Alright, same mass, but now they use powdered magnesium oxide instead of large lumps. So I hope that you remember the magnesium. Okay, guys, another thing, guys, another thing. Yeah, remember that this hydrogen peroxide question is, it is a very common experiment that you all need to know. There are certain experiments under certain topics that you absolutely need to know. So for rate of reaction and under catalyst, right, this is a sample experiment, right, that you absolutely need to know. Okay, just another example. I was teaching the year 10s yesterday. For empirical formula, do you all remember the experiment that you are supposed to memorize for empirical formula? Can someone please give a brief description on the experiment that under the topic of empirical formula? Anyone? What is the what is the experiment that you need to know and memorize under the topic empirical formula? You all don't remember? Yes, Ian, it's the crucible and the lid. Alright, it's the crucible and the lid. What is the name of the chemicals inside, Ian? Sorry, Ian. Do you all remember the name of the chemical inside the crucible and the lid? Yoo-hoo, are you there? Yes, so it is the addition of oxygen to magnesium. So you're gonna get magnesium oxide. Okay, alright. So the best thing about YouTube is, yeah, I can see that y'all are lagging. The best thing about YouTube is you can go back and watch it later, right? Okay, yes. So, Ian, I have not forgotten your answer. I have seen your answer. So, the answer to this question is, right, sketch. So they use powdered magnesium. Also, when you use powdered, right, your surface area increases, your particle size becomes smaller, so there's more area for collision. So this is what you are going to get, right? So that's the answer. Yes, it is a graph with steeper gradient. Steeper gradient means the rate of reaction is higher. What does it mean when the rate of reaction is higher? That means the reaction is faster and it finishes earlier. Right? So as is clear with the red line. So please add the red line to your paper. Moving on. Alright. Uh, for part D, I have the answer here. No. For part D, we have written down the answer at the beginning of class. There we go. So please put all 4 points in, okay, for part D. So I hope that you have a device or the paper or whatever platform that you are comfortable with, but I hope that you are keying in or writing down the answers as the class is going on, right? Because I'm not going at ultra top speed, yeah? I will give you time to note down and to take down, okay, and at the same time chat with you on the live chat. So the best thing about this is, you are not heavily dependent on my voice. All right, the visual will be good enough. So that is the answer. Are you all comfortable for me to move on, or you all need some time to take it down? Okay. Okay, I'm glad that you all are having fun. But are you all done with this? Can I move on? Okay. Alright, so I'll just move on, yeah? So Junkit, you have to watch it later, okay? Yes, I'm moving on. Okay, here we go. This is all our favorite, right? Stoichiometry. So the name of the chapter that involves the calculation is stoichiometry, yeah? So remember, the first thing that we do is we find the moles. Okay? We find the moles. We find the moles of whatever quantity is given to us, in this case hydrogen peroxide. All right? So okay, so using so they want the concentration of hydrogen peroxide. Okay, so let me write the equation down. So this is in gas, and they gave to us that this is 48 centimeter cube, right? So immediately I know this is 0.0448 decimeter cube. Okay, so we are going to use the 48 centimeter cube to get the moles. Okay, so the moles equals to volume over 24. So it's equals to 0.048 divided by 24. Okay, so you're gonna get 0.002 moles. Do you all follow so far? So this is the first answer. So this is 0.002 moles. So this is 1 and this is 2. So immediately you know this is 0.004 and 0.004 respectively. Do you all follow? Do you all understand so far? Okay. Alright, so let me know if I'm doing something wrong or you all don't understand. Okay. Now, deduce the number of moles of hydrogen peroxide that decompose. Well, this is the answer. Okay, so it's 0.002 times 2, you're going to get 0.004 moles. Okay. So now the next step is they want you to calculate the concentration of hydrogen peroxide. Well, the concentration of hydrogen peroxide, the concentration is mole over volume, right? So the mole is 0.004 and the volume is 0.025. I hope you know where we got the 0.025 from. Okay, the 0.025 we got it from, this 25 you divide by 1,000. All right, because that is the unit of decimeter cube. Yeah. So it's 0.16 mole per decimeter cube. So I'm going to leave this on here for a while. Okay, if you have any questions, please, I want to see them in the live chat. I hope this is helpful. All right, so let me know whether you agree. Very good, Alicia. Wow, the formula only works with decimeter cube, Ian. Alright, Ian, the formula only works with decimeter cube. There is no formula that I have taught you that works with centimeter cube. All the formulas that I've taught you works with only decimeter cube. Okay? So when you want to convert to decimeter cube from centimeter cube, you've got to divide that by 1,000. Okay, take your time, take your time. Okay, if you are done, maybe you can give me some cue to move on. Like, okay, teacher, let's go. All right, Manraj, let's go. If there's anyone that really wants me to wait, you can key in. Please wait, yeah? Okay, moving on. Oxygen can also be produced by the decomposition of potassium chloride. The only products of this decomposition are potassium chloride and oxygen. Okay, shouldn't be too difficult, right? So, KClO3, okay? So you decompose it and you get potassium chloride and oxygen. So the only real difficulty is to balance the equation. All right. So in the chat below now, can you just, you know, give me the numbers like 323 or 142? You know, that's how we normally do it in class, right? Can I see some answers? 223 says Alicia. Wow. Someone is very on top of things, yeah? So 223 looks about right. Looks about right. Well done, all of you. Thank you for your participation. I'm having a bit of mixed feelings. Guys, should we do one more rate of reaction or should we jump straight to organic chem? Can I have some opinions? Should we do one more rate of reaction or should we jump straight to organic chem? Okay, so in that case, let's move on, but please make sure you do the rate of reaction question on your own, right? Okay, so let's move on. So remember, you have 12 organic chem MCQ for tomorrow. Can I see some answers here? Okay, very good. Well done. Can somebody write down the name of the link? What is the name of the link in A? Very good, very good. So A is the amide link. Okay, B is the amide link, and Starch doesn't really have a proper link, it's just oxygen. All right, nylon is amide. Okay, nylon is amide. Okay, and I hope you remember terylene is ester link. So the answer to this question is A. Next question. Thank you for participating. Wow, this class, everyone gets the correct answer. Huh? Everyone puts A. Okay, Manraj. Esther Ling for the last one. That's right. What about this question? Wow, you're quick. Okay. I hope there's no confusion here. Okay. The answer is D. The name does not change, guys. The name does not change, even though the double bond broke, but the name does not change. Oh, so this turned out to be a very good question, right? The name does not change, although the double bond broke and is now single bond, but you don't change the name to ethane. Maintain it as polyethene. So the answer is D. Very good. There's nothing to understand. It's just you got to know lah, right? You just have to remember that. Huh? Okay, moving on. So I hope you know. Hi, Ziyan. I think you just came in, is it? Huh? Okay. Anyway, in the next question, I hope you are on top of things when it comes to fermentation. All right, fermentation and catalytic hydration. Those are the two methods of making alcohols. Okay. So catalytic hydration uses fossil fuel and fermentation uses carbohydrate. Absolutely. So, guys, the answer is D. Very good. So, it's anyway, multiple choice is a fantastic avenue to do some revision. So, A. So now you know that fermentation is not a rapid reaction, right? B. Fermentation does not produce purer products. You know that catalytic hydration produces pure product. Fermentation, guys, fermentation requires a two-step purification process. Can you write down the two steps of purifying the products of fermentation so that we get ethanol? Write down the two steps of purification. Ian, is that the first or the second one? It's the other way around, guys. Yeah, it's the other way around. It's filtration, then fractional distillation. Okay. Yeah, filter first, then you do fractional distillation. So remember, filtration, right, is to remove the yeast, the unfermented carbohydrates, and then the fractional distillation is to separate ethanol and water. Very good. Okay, moving on. So, and fermentation, yeah, it's an exothermic reaction. Guys, fermentation is an exothermic reaction. So it doesn't use a high temperature. It produces high temperature, which you've got to cool down. So usually, where they do fermentation, it is kept in a relatively cool place. If not, when the heat goes up and temperature goes up and up and up, what will happen to the enzymes? The enzymes will be denatured, and then the fermentation will stop. Moving on. Very good. Okay, so I hope that you all remember what I told you all about eliminating, all right? I mean, it is very clear, all right, that cracking produces three things, okay? Cracking produces smaller alkene. Ultimately, this is what we want, okay? Why do we want smaller alkene? Because they are better fuel, all right, and they can be, used to make ethanol and polymers. So ultimately, guys, alkene, the smaller alkene is what we want. So immediately, D is not the answer. Sometimes we get smaller alkanes, all right, and sometimes, very rarely, we get hydrogen. We never get water. In fact, if you look at B is the, that cracking does not produce water. So automatically, yes, you all are right. The answer is B. Guys, look at all of you. This class is really good because all of you get the same answer most of the time. Absolutely great. Moving on. Oh, the fractions. Let's get the right answer for this first. Okay, yes, the answer to this question is C. All right, now since C is the correct answer, let's learn. Like I told you, multiple choice questions, right? Multiple choice questions, they are very good for revision. So I want you to key in how do you make A, B, and D correct. For example, E, you should put, for example, bitumen. Yeah, can you please, uh, make A, B, and D correct by typing down an example of what I have typed. Do you understand? So someone do A, someone do B, and someone do D. A is absolutely right. A is refinery gas. Yes, I know, Manraj. So A is done. Can someone quickly do B and D, please? That's how we learn from multiple choice. Can somebody please correct B and D? Can you please put the alphabet, Alicia? You're killing me. Yeah, B is kerosene. Very good. Anyone knows another name for kerosene? Anyone knows another name for kerosene? Yes, D is. So we have A, B, and D all done. Thank you very much. Another name for kerosene, please. Very good. Guys, another name for diesel, please. Another name for diesel. Another name for diesel. Does anyone know? No, Ian. Another name for diesel. Please learn this, yeah? Yes. Very good, Dion. Okay, let's move on. Alright, so now we are going on to paper 4, the structured questions. Okay, can somebody please have a go at this? Can somebody please try number 1? Yes, so you have alkene and alkane, yeah? So remember, you can put any combination you want, right? Just have a smaller alkene, alright, plus a smaller alkane. Okay, now if you want to get hydrogen, okay, if you want to get hydrogen, then it's C10H20 plus hydrogen. Okay, so you can basically put any combination you want. Okay, moving on. Propene can be made by thermal decomposition of chloropropane. How chloropropane can be made from propane? So you need, if you want chloropropane, what are the reagents? You need propane and, do you understand the question? Can we do part 2, please? Yes. Yes, all right. Of course, they would prefer UV light. Yeah. So chlorine, okay, UV light and heat. Yes, this is chlorination, and this reaction also starts with, yeah. What is the name of this reaction that starts with an S? So remember guys, as I'm waiting for the answer, remember this is, we are in revision class, so we are just not just very good. So we are just not interested in writing down the answers. We want, based on this, we want the questions to be a point where we can expand and revise. So I hope that you all remember that substitution, we do not get pure products, right? Substitution, we do not get pure products. Okay, so we get many different combination of products, and I hope you understand what we mean. So a lot of them are isomers. Okay, same molecular formula, different structural formula. Moving on, there we have it. Yeah, so we say that, okay, so we say that they are, so for B, all right, so you say that they are molecules. Guys, it's best to start with a subject. Okay, so molecules with the same molecular formula, okay, but different structural formula. So of course you know the okay guys, can somebody please in the live chat key in the molecular formula for these two compounds? Can somebody please key in the molecular formula for these two compounds? Thank you, Dion. Somebody please key in the molecular formula. Absolutely right. What Ian keyed in is the molecular formula. Alright, let's move on. Give the name and structural formula of another hydrocarbon that is isomeric. So remember, alright guys, I need you to understand. Can you listen, please? You are given two isomers there. Alright, and the second isomer is very complicated. Okay, now remember we did this exercise in class. Can you please give me the name of the second isomer, the one on the right? Can you write down the name of the second isomer, the one on the right? Is that Hans? Is that on purpose? I don't get that joke, you know. But anyway, guys, can I have the full name for the isomer on the right? What is that, Ian? I want the full name, guys. Wow, Jia Yan, very good. She's really studying very hard. Correct. So you know that 2-methyl propene is very complicated. Usually in the example, they will give you something complicated so that they want you to write down something simpler. So for part B2, can you write down the name of the third isomer that is very simple and not complicated like what Ian has written? Can you try? It's a simple isomer. Remember, when they require you to write an isomer, they usually will require the simple isomer. Because what Ian has written and what is provided on the right is more complicated. The chat is very quiet, guys. Guys, are you all there? Guys, are you all there? Just let me know whether you're still there. Dion, that's not right because that is what is given in the question. The first one is put one in, the second one is what Chia Ian wrote. Now, what is the third one? Guys, it is put two in. Okay, it's a simple one. So the name is put two in. Okay, and yeah, okay, so yeah, yes, okay, or I will write it out, I will draw it out. Okay, never mind. Okay, so I want you to take a look. Okay, they gave you, okay, this is given. Okay, put one in. Okay, now the other one that is given, it is 2-methyl propene, and what they require is something simple. Put two in. Now I hope you will listen to me. Okay, In the example, they did not write butuin as the second example. Why? Because it's going to be very difficult for you to come up with the complicated one. So they gave you the main one and came up with a complicated one. So they are helping you, to get the simpler one. I hope this is clear and we have spent too much time on this. Any questions? Write them down. If not, I have to move on. Okay. Um, Just now we had substitution, right? Now this is addition reaction. So this is the addition reaction. So it's a good, this is a good revision. Um, it's a good revision. Okay, so you need to memorize alkene react with steam, what do we get? Alkene react with hydrogen, what do we get? Alkene react with bromine, what do we get? Can you please write your answer in one line, not separated, okay? Which one is this? Write them in order, okay guys? Write them in order. Guys, don't give single answers like this. Write 3 in a row. In order. Absolutely right. Okay, guys, they will not require the detail of Manraj. They will just require Ian's answer for the last one, the bromobutane. Okay, so it will be butanol, butane, and bromobutane. So those are the answers. Look at Ian's answers. Those are the answers. Now, but this is a point of revision for us. Alright, so now you remember that alkene plus, okay, alkene plus water, you get alcohol, right? Alkene plus hydrogen, you get alkane, okay? Then alkene plus the halogen, okay? Yeah, so plus of course Br2, then it will be bromo, okay? The bromo alkane. Yeah, so this is a good revision, okay? Yeah, they do not require the level of detail as per Manraj's answer. Okay, so if there's any questions here, please let us know. If not, we are moving on. Okay, so this one is addition polymerization. Now, can somebody in the chat please quickly type down the definition of addition polymerization while the rest of you all try and get the name of this monomer. Yes, Alicia, absolutely right. Yes, halogenoalkane. Very good. Okay, what's my question? Yeah, somebody give me the definition of addition polymerization. Correct, huh? So, yep, so you look at this one here. So remember to get the monomer, remember the king and the queen here used to have the double bond. Okay, so when you draw the monomer, you can maintain this orientation if you want. Okay, um, yeah, so that is your propene. Okay, so this is your propene. Very good, very good. Okay, uh, yeah, correct. So yes, only one product form, no loss of material, no loss of atoms. Thank you, Alicia, Manraj, and Ian. So yes, that is propene. Of course, if you don't like this orientation and you just want to draw something simple, can you? Absolutely fine. So the name of the monomer is propene. Shall we move on? Oh, okay. Can you all try this question? Pergi cari mereka, atau mereka di mana? Belakang. Wow, guys. So this is an addition polymerization question. Wow, it looks okay, honestly guys, I haven't seen a more difficult addition polymerization question, and there's no way how you can show me your answer in YouTube live. So I'm going to draw it out for you. Okay, you just try it out on your own. Okay, so now this is the question. Okay, so you have C double bond C, H, 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 O, C, O, CH3. So guys, let me see whether you all have any questions. Okay, so please listen up. Yeah, so I'm going to explain here. So if you know, well and good. If you do not know, I hope you learn from this. So for addition polymerization, we are only concerned about the king and the queen, right? We are only concerned about the king and the queen. Can you identify the king and the queen or not? I hope you can. The king and the queen, they are the ones with the carbon to carbon double bond. The rest, we don't care. Only one product form, no loss of atoms. So we are only concerned about our king and the queen. So once you identify the king and the queen, there's no loss of material, no loss of atoms. So everything just maintains. Everything just maintains, right? So this H, draw it out. I'm done. Okay? This H, draw it out. Done. Okay? This H, you have the choice to draw it up or down. It's absolutely fine. Okay? This H is done. Alright, now what's going on here? O, right? C, O, CH3. That's absolutely fine. So this is the answer, guys. Now, of course, there are some students that don't like to present their answer this way, okay? And they would like to present their answer in another way. Let's explore the other way. Okay, so remember, we usually, if you want to write in a molecular form, you have to start with C and then H and then O. Okay, so yeah, so it's O, C, O, C, H3. That you can also write like that, is absolutely fine. But for me, I'm going to write it this way because it is clearer. I hope this is clear to you. Alright, any questions or not? Okay, so this is quite tough. Alright, this is quite tough. I personally have thank you. I personally have not seen a more difficult addition polymerization question before. Now we have to move on. Okay, now this is environmental chemistry, yeah? Environmental chemistry. So polymers, yeah, polymers, they are like plastics, right? So what is the environmental cost to our planet? So remember, describe the pollution problems caused by the disposal of polymers in landfill sites. So remember, for landfill sites, for landfill sites, you say they are non-biodegradable. Now, the fact that they are non-biodegradable means that it's not going to go away. Alright? So the landfill sites are going to increase in size, and they are therefore going to cause visual pollution. Alright, there's not enough space. Okay, and you wouldn't like to live next to one, right? Because in the past, when there were not so much plastic, whatever you throw, it's organic in nature, they will decompose and the landfill will, and then you can keep on throwing new stuff. But nowadays, plastics, especially now when we are not able to go out to get food, we do our tapao home, and then most of the things there is plastic, right? Non-biodegradable. So that's the problem with the landfill sites. What about burning? So remember, for burning, you're going to get toxic fumes. Okay, yeah, burning is a way of just getting rid of the waste. You just burn it, they will go. But what is the cost to the environment? You're going to be having toxic fumes when you burn the polymers. I hope this is clear. But guys, we're talking about landfill sites. There's no fish there. Landfill sites, they are where you throw the rubbish. Is there some form of confusion here that you would like to clarify, guys? No, it's the toxic fumes, okay? Now we have to move on. All right? Okay. Now we are going on to question number 4. Now I hope that you remember that we talked about this before, that if they are all volume, if they are all gases, the moles, okay, sorry about this, the moles, right? uh, okay, the moles can represent the volumes of the species, yeah. Okay, so now what they are telling us is that 3 is 15, 5, and of course this is 1. What is the volume? Do you all know? Are you clear on this? Jayshree, write down the volume of the hydrocarbon and the oxygen for me, please. Thank you. 5 and 25. So the factor is by 5. What about this one here? Can somebody write down the volume, please? What is the volume of water? Is the volume of water 20? Why cannot Hans tell them? Why not? Why can't we identify? Yes, it is not a gas, it is liquid. So you can't tell, okay? Very good, very good. Thank you. Well done, well done. So you got to be aware about that, right? Okay. So now we have propane reacting with chlorine. So write an equation for this reaction. Pretty straightforward, right? So we've got a C3H8 plus chlorine. Okay, and then we got a C3H7Cl plus. Can you all complete this for me? You can do it. Sorry, Jayshree and Miyoko, because the rest of them, they are, uh, it's quite real time for them. So, I think the problem is on your side. Okay, never mind. That's right. Chia Ian, it is HCl because you took one hydrogen away and you only took one chlorine into the main organic compound. Okay, so HCl. Okay, it's okay, Miyoko. You just try your best to follow lah. Nah? Okay, very good. What type of reaction is this? We have talked about this. What kind of reaction is this for part 2? So this is the answer to part 1. For part 2, do you all remember? Substitution. Yes, Jayshree, it definitely is your Wi-Fi. Moving on. So it's substitution, Substitution, okay? Substitution. Moving on. Okay, so we have done this just now already, right? So for C1, you've got to define the term isomer. And then you got to give the example and another example. So that's how you get all 3 marks for this question. Okay, so remember we already did the definition for isomer. You must start with what? Molecules. Okay, with the same. Okay, with the same same molecular formula but different structural formula. So give an example. What is example 1 and example 2 using propanol? You can do it. Come on. Tell me, what are the 2 examples? Very good. So it is propan, 1 all, and propan to all. So those are the two examples there. Okay, so yours is a bit incomplete now, Manraj. Okay, now fractional distillation can separate two propanols. Why? So you know that fractional distillation works on the basis of what would you put as the answer for part 2, guys? What would you put as the answer for part 2? Correct. Different boiling points. So it's on the basis of substances having different boiling points. Yeah. So oxygen can oxidize propanol to propanoic acid. Name another reagent that will bring about this reaction. Now, if you can answer question 3, yeah, I will be happy. Try. Very good, Manraj. Very good. So that is a very popular oxidizing agent. So please note it down in including the Roman numerals, guys. Yeah, remember, there are some past papers that give you 1 mark for potassium manganate 7, and another mark for acidified. So it's very, very important that you write acidified potassium manganate 7. So certain things we just have to memorize. Okay, certain things that we just have to memorize. Okay, very good. Propanol, okay, now we've come to esters. Okay, now we have come to esters. All right, so I hope that you're okay here. Very quickly, can somebody key in the name of the ester, please? Because you cannot drop. Actually, can you in one line write down the name of the ester and also the structural formula? All right, I will show you an example. Okay. That will be an example, correct or not? Now, if you are able to come up with that structural formula that I'm showing you as an example, guys, that the one that I'm typing is not the answer, yeah? It is an example, okay, of the ester and the structural formula. So I want you to try out. So all of you all know is propyl propanoate. Can you very quickly come up with the structural formula of propyl propanoate? Can you? Okay, the response is low, so very good, Alicia and Ian. Very good. Now, you will find that if you are able to do this, that means you are very confident. You are very, very confident. Huh? But for those who are struggling, I will show you. Huh? So remember, for the names of the ester, okay, ester has two names. Remember, the first one comes from alcohol and the second one comes from the acid. In this case, both the alcohol and the acid, they are the third carbon member, correct or not? So it makes life simpler for you. Propyl propanoate. And when you come to drawing esters, remember to start with the functional group. Okay, and I hope that you remember that this is the acid, and therefore this is the alcohol. So the acid is propanoic acid. So propanoic acid has 3 carbon atoms. 3. So you have 1, you have 2, and you have 3. And the alcohol is propanol. So you also have 3 carbon atoms. So 1, 2, and 3. So how do you come up with that structural formula? C2, H5, COO, C3, H7. That's how you get the answer. So I hope this was helpful. If you're facing any difficulty, please write it down. If not, we will move on to part D. Propene can be made by heating propane and sulfur. Wow. So another way of making alkenes from alkanes. Very good, very good. So thermal cracking, heat and catalyst. Actually, with the word thermal there, heat is Alicia, there's no such thing, Alicia. There's no such thing. Okay, it's thermal cracking, Alicia. Okay. D2. Outline how propanol could be made from propene. It's okay, Alicia. It is okay to make mistakes in our class, right? Okay. So now for the last question on the screen, I think in total you will need 4 information. So can you give me the 4 points that you need for the last question on the screen, please? Very good. So it is catalytic. Yeah. Absolutely right. Very good. Very good. I think is this the one whereby the textbook used 570 degrees? Does the textbook use 570 degrees Celsius? Can someone please check? Okay, then we should change to 570 degrees Celsius from now on. Okay, well done, all of you. Moving on. Okay, alkenes are unsaturated hydrocarbons. What does unsaturated hydrocarbon mean? Can I see your answer in the chat? Write down what you think unsaturated hydrocarbons are. Correct. So unsaturated means carbon to carbon, double bonds, alkenes, that's right. So for 5A, it's an open-ended question, not just double bond, yeah, carbon to carbon, double bond. Yeah, so for 5A, it's an open-ended question, right? So just choose something simple, just choose something simple like, let's use our butene, C4H8. Okay, and then you draw boot 1 in, and then you draw boot 2 in. Okay, I hope you know how to draw. Okay, I hope you know how to draw. Okay, so you can draw a 1, 2, 3, 4, 1, 2, 3, and 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. Yeah? So I hope this is clear. Is this clear? Is anyone lost? Okay, if you are, please let me know that you are lost. We have 3 minutes left, so we will just do one more slide and then we will call it a day. So we will do a bit more, maybe I'll do question 6 and 7 before the test tomorrow. Okay, so you do your homework, right? You try to fill it up and then you compare answers. Let's just do one more slide. Yeah. So this is pretty much the same as just now. So maybe I'll just quickly go through here. So remember ethene and steam. So the product is ethanol. Okay, so to draw ethanol, yes, the rest are hydrogen. And if you react with hydrogen, you are going to get ethane. So yeah, there is no more double bond, so 6, so C2H6, this one is C2H5OH. So this one we have done in the previous question, so I hope that's not going to be a problem. Let's try and do one more slide. Okay, so maybe we can stop here after this question. So explain the term polymerize. Okay, so we say that the linking up of monomers, okay, to form a giant molecule, okay, with a long chain. Yep, so that's how you explain the term polymerize. Okay, and I hope you know the difference. Sorry, this is 1, yeah? This is 2. I hope you know the difference between addition and condensation polymerization. So addition polymerization, remember, only one product form, okay, no loss of atoms or materials. But what about condensation polymerization? Put it down in the chat, the definition for condensation polymerization. Can you be a bit more specific, please, Manraj, for condensation polymerization? Yeah, so you get more than one product. Usually you get 1 watt and 1 watt. Yes, the small molecule that you're going to get is usually water, and the other product is the polymer. So for condensation polymerization, all right, the difference is you get a polymer and a small molecule. Usually it is water. Very good, Ian. Ian, where did that come from? What do you mean by HCl over there? Confusing everybody. Can you explain what do you mean by HCl? Okay, yeah, so it has nothing to do with HCl. So, yeah, so currently, that's it for me currently. Thank you. If you have questions, what HCl? For which one? For condensation polymerization? What? There's no HCl. Okay. Now, anyway, that's the end of our lesson. Okay, there's no HCl, in this context. Okay, maybe Manraj, you can take a picture and show me on our messenger. But that's the end for today. Yeah. Okay. Yeah, that's the end for today. So if you have any questions, please put them in the live chat now. If not, I hope you enjoyed the lesson. Remember, the link, the video will be available. You can just click it and watch it if you missed any parts. Complete the rest of it, guys. Complete the rest of it. and tomorrow we will discuss the rest of the questions. So that's it for our class on rate of reaction and organic chemistry. All the best tomorrow. Bye bye.